Welcome to the flipped lesson over derived units, temperature conversion, and density. Let's get started. In class, we discussed how there was SI units, the accepted measured units for certain items. For instance, mass is measured out in kilograms as the SI unit, and length was meters. So let me talk about some derived units. And what derived units are is combinations, which I believe this is going to be your blank, combinations of quantities. There's an extra little blank there that's just extra on the page. You do not need it. And what these are is they're combining some of the SI accepted units to make other units. And so the first one would be, that's supposed to be meters squared, which would be how we would write area, because it would be length times length. Density is going to be mass over volume, which we're going to talk about density quite a bit here in a minute. And then centimeters cubed is the same thing as a milliliter, and that is actually volume. And the way that they get that, and it's a derived unit, is centimeters cubed is this. They've done those calculations, but they're obtaining that by saying that volume is equal to length times width times height, and so that's where they get the centimeters cubed from. And this is an important conversion factor right here that we will use quite a bit this year. So you need to probably go ahead and memorize that. And that is a centimeter cubed, and again it's supposed to be cubed, is equal to 1 milliliter. They are equivalent. Sometimes we also call that a cc in the medicine world. If you get a shot and it's 2 cc's, that stands for cubic centimeters, so that's where that cc comes from. Okay, let's take a few minutes to discuss temperature. And so one thing you will have to be able to do in this class is to be able to convert between Celsius, degrees, and Kelvin. And it is the easiest calculation of all. First of all, let's talk about what absolute zero is. It's a temperature where all molecular motion ceases to exist. Okay? And we talked about that in chapter 1, where we talked about how all particles have some sort of motions. Remember, solids are vibrating in place, liquids can slide past another, and of course gases can move freely. But at 0 degrees Celsius, Kelvin, all particles cease to exist. And when we're writing the Kelvin temperature, we do not use a degree sign. It's just K. Now, interestingly enough, we have not actually ever reached absolute zero. We've come really, really close, but it's really more of a theoretical thing that if we actually did reach 0 Kelvin, that all particles would cease motion. And if you look here, like I said, it is the easiest conversion factor. If we have a Kelvin temperature that we're trying to convert from Celsius, all we do is add 273. It's actually 273.15, but we drop off that 15. So if you ever see that somewhere, it's just because it doesn't really make a huge difference for our calculations. And of course, if we were wanting to go the other direction, if we had a Kelvin temperature, we would subtract 273 from the Kelvin temperature to get back to the Celsius temperature. And so here, if I converted 98 degrees Celsius to Kelvin, I would simply add that 273 and get 371. And so here, it says we want to convert 250 degrees Kelvin to degrees Celsius, so we would say 250 Kelvin, and since we're going the opposite direction, we would actually subtract 273, and that we would get a negative 23 degrees Celsius. So that's how we would do that. So this slide is just here to kind of show you how you can relate temperatures that you're used to thinking of. I know we said we wouldn't be using the F word, Fahrenheit, in class, but I did want to show you so you can kind of wrap your mind around the differences in temperature. So we know that water freezes at 32 degrees Fahrenheit. So that would be 0 degrees Celsius and 273 Kelvin. Water boils at 100 degrees Celsius, which is equivalent to 212 Fahrenheit and 373 Kelvin. And then, of course, if you look at 0 Kelvin, absolute zero, that would be a negative 273 Celsius, but it would be a negative 459 Fahrenheit. Alright, so the bulk of this lesson is going to be density, and we will be doing a lab over density, so you need to make sure you understand how to do these calculations. First of all, let's start with giving you the formula for density. It is a relationship of mass to volume, and so when we write this, it's density is equal to m over v. okay, which is mass divided by volume. And so it's a super easy calculation in that it's just a division problem, but it does have different units depending on what state of matter we're in, and we need to be aware of that. If it is a solid, our units are going to be grams per centimeter cubed. And so because you would ultimately be doing the meters is times a meter for length times width times height. If it's a liquid, it's going to be grams per milliliter. And remember, I told you that a centimeter cubed is the same thing as a milliliter. We tend to use milliliters for liquids and centimeter cubes for solid. And then if it's a gas, because they have a very, very low density, we actually report that in grams per liter. So you need to be aware of that. Also, the other thing that we will be using is density as a conversion factor, meaning we can use it either 1 gram is equal to 1 mil or vice versa. So water has a density of 1 gram per milliliter. You need to know this. We will use this throughout the year, which means that 1 gram of water is equal to 1 milliliter. So I can write this conversion factor like this: 1 gram per milliliter, or I could say 1 milliliter per gram. Either way, it's 1, okay? So make sure you try to remember that. It's an easy number to remember. Matter of fact, you really need to know all the three big things about water: that the density is 1 gram per milliliter, that it boils at 100 degrees Celsius, and that it freezes at 0 degrees Celsius. So when we're thinking of density, we can kind of think of it being as a concentration of matter. Something that's really, really dense is going to be very concentrated. And then something that's not very dense is going to have a lot more space between the particles. And so if you look at these two cubes, clearly this cube right here has a higher density. In class, we use the example of if I had a pound of feathers and a pound of gold, how much volume would I have? And we said we'd have a lot more volume of feathers because feathers are not very dense. So it would take a lot of feathers to equal 1 pound, whereas gold is very, very concentrated matter. It's very, very dense. So it wouldn't take much gold to equal a pound. So that is kind of something to keep in mind when you're thinking of density. Now, in terms of density of liquids, liquids do have a lower density than most solids. The one exception to that is ice and water. Ice in its solid form is actually less dense than its liquid form, but that's the only substance that's like this. But when we have different liquids and the densities are different, they'll either float or sink, depending on if it's more or less than water. In this case, we have oil and water, and the density of the oil, and this is just vegetable oil, the density of the oil is 0.95, that makes a big difference, the 0.95 grams per milliliters. Whereas water, we said a while ago, and remember we have to memorize this, is 1 gram per milliliter. So because of this, the oil floats on top of the water. That's why when you see on the news, when you talk about an oil spill or whatever, and it stays on top of the water, it does not sink down, and that's because it is less dense than the water. Now, when we are calculating density, the first thing we need to do is we need to determine what mass we have, or how many grams the object is taking up. Then we need to determine the total volume that mass occupies. In the case of irregular shaped solids, we're going to use something called water displacement. And what that is we would measure the initial amount of water we had in a container, and then we would lower our object into the water, and then we would see how much the volume rose, and we would subtract those two numbers, and that would be the total volume that our object took up. We are actually going to be doing this when we do our density lab. We're going to do density of several different metals, and they're going to have a little hook and a string, and we're going to lower that in there, and we're going to see how much did the water level rise when we added that object, and the amount that it rose will be our mass of our not our mass, our volume of our object. And then, of course, the last step is to divide the two numbers and report your density answer in units. And remember, for solids, we use grams per centimeter cubed. For liquids, we use grams per milliliter. And then for gases, we use grams per liter. Okay? All right, so let's try this example problem. It says we have an unknown metal having a mass of 287 grams, so that's going to be our mass, and it was added to a graduated cylinder that contained 31.47 milliliters of water. After the addition of the metal, the water level rose to 58.85 milliliters. So it says calculate the density of the metal. So first thing is we're going to write our formula, which is density is equal to m over v, which is mass over volume. We're going to define our terms. We said mass is the 287.8 grams. And then our volume, we have to do a quick little subtraction problem. Because we are adding it to water and the water level rose, we know that this is water displacement. So we're going to get our volume by starting with the 58.85, and we're going to subtract the 31.47, and then we get that our total volume of our object, or our piece of metal, is 27.38 milliliters. So now that we have our volume and our mass, we can quickly go over here and we can say mass divided by volume. So we can plug in 287.8 grams divided by 27.38 grams milliliter. And then when we do that math, we get that that equals 10.51. And then remember, there's no naked numbers, so we have to put our units, and our units are grams per milliliter. Okay? So what that means is that 10.51 grams is equal to a milliliter of this object. So we could also write it this way: 10.51 grams is equal to 1 milliliter. Or we could say 1 milliliter would have a mass of 10.51 grams. So this is a fairly dense metal that we're dealing with. Okay? So these problems need to be solved on the left side of your notebook, and so you can just write them in the work on the left side. I believe it's going to be page 16, but double check me, I might have that wrong. But I did want to give you a little bit of a hint on this one right here. It says a solid has these dimensions, and it has a mass of 28 grams. It says, will this solid float in water? So what you're going to have to do is you're going to first of all have to decide what the volume is, and that's where you're going to use the volume equals length times width times height, and that will give you your volume. And then solve for density of the metal, and then compare it to the density of water. If it is greater than water, then it's going to sink. If it's less than water, then it's going to float. So that's a little hint for you. So hopefully you've watched this video before we do labs. It'll make your life a little bit easier when we do the lab. Stay tuned for the next slide for our jokes. Instead of jokes this time, we're going to do periodic table puns. So all the answers to these are going to be periodic symbols. And we're going to start with one of my all-time favorites, and that is, what is the name of a goofy convict? He is a silicon. And the next one, what a cloud does? It uraniums. And then the last one, what you do in a play. In a play, you act in them. All right, that ends our flipped lesson. See you in class. Have a good day.